Okay, so we are looking over some of the problems from the 5.3 homework. You didn't get a gift B? Did you get a gift A? Okay, on gift B, we are looking at number 7 from 5.3. So this is 5.3 gift B, number 7. And it says 2 secant squared x plus tangent squared x minus 3 equals 0. Did you make a substitution?
Yes.
What did you plug in?
1 plus tangent squared x.
For secant squared?
Yep.
So 1 plus tangent squared x is the same as secant squared x, right? And so now I can distribute the 2. I get 2 plus 2 tangent squared x plus tangent squared x minus 3 equals 0. Combining my like terms, do I get 3 tangent squared x? And then the 2 and the minus 3 is a minus 1. Does that look okay?
Yep.
And then I add 1 to both sides. And I divide both sides by 3. And we are getting tangent squared x equaling 1/3. Did you take the square root of both sides? Did you remember the plus or minus? So we've got tangent x equaling plus or minus square root of 1 over square root of 3. But I'm going to multiply that by square root of 3 over square root of 3. So I end up getting plus or minus square root of 3 over 3. Is that correct? So then we're looking at our unit circle. Where on our unit circle is the tangent equal to square root of 3 over 3? My money is on either pi over 6 or pi over 3, because those are the ones that have square root of 3 over 2 in it. And is it pi over 6?
No, it's pi over 6.
It's pi over 6, right? Because if I take 1/2, I want my y over the x, right, for tangent. So I want 1/2 over square root of 3 over 2. That's 1/2 times 2 over square root of 3. And I get 1 over square root of 3, which we can multiply and get square root of 3 over 3. So we like this answer of pi over 6. We don't want the pi over 3. That's all that we want. So I want pi over 6 as my answer. And would we agree that we would also want, or another positive one would be across from it, right, at, thank you, 7 pi over 6. And if I want the negative square root of 3 over 3, I'd be here at 5 pi over 6 or here at 11 pi over 6. Are we agreeing on this? Is this okay? And they only wanted the solutions between 0 and 2 pi, so I think those are going to be your 4 answers. Dan?
So let's say then say 0 and 2 pi. Would our answer just be pi n over 6?
I would say pi over 6 plus pi n, where n is any integer, and then also have to list 5 pi over 6 plus pi n, where n is any integer. Okay? All right, should we look at number 8? All right, for number 8, on gift B, it was 4 times tangent squared x minus 1 equals tangent squared x. I would subtract tangent squared x from both sides. So I get 3 tangent squared x minus 1 equals 0. Add 1, divide by 3. And doesn't this look like it's the same problem?
Yes.
Is this going to be the same answers?
I believe so.
I don't think there's any difference in your solutions. I would say you take the square root, plus or minus. I'll say C number 7, right?
Okay, so, like, since tangent's on the other side, like, in what terms do you not subtract, like, so the tangent didn't have, like, the square, and it was just, like, tangent x?
If you have a tangent squared and a tangent without a square,
Couldn't subtract it, like, that's not the same.
they're not like terms, but I probably would still want to get them on the same side and maybe try product sum. Yeah. Okay, should we look at number 9? Yes? For number 9, it says cosecant squared x minus 4 cotangent squared x equals 0. Is it 1 plus cotangent squared is equal to cosecant squared? You guys are all working on memorizing these, right? Because for this test, you have to have all your formulas memorized. All right. So if I plug in right here, no, that's not what I plug in. If I take out the cosecant squared x and I replace it with 1 plus cotangent squared x, is that true? Minus 4 cotangent squared x equals 0. It looks like I get a negative 3 cotangent squared x plus 1 equals 0. Subtract 1, divide by negative 3. I get cotangent squared x equals 1/3. Take the square root of both sides. This looks like a pretty similar problem to what we were doing. I get cotangent x equals plus or minus square root of 1 over square root of 3, which is going to turn out to be plus or minus square root of 3 over 3, right? But now we're talking cotangent, so we want the x over the y, not tangent where we wanted y over x. So I think in this case, for our circle, we are going to want pi over 3 instead. Would you agree with that?
Yes.
Because we want 1/2 comma square root of 3 over 2, so the x over the y, 1/2 divided by square root of 3 over 2 is going to end up being square root of 3 over 3. So I think we want that solution, and we want the one across from it, which is 4 pi over 3. And then for the negatives, we would want the 2 pi over 3 and the 5 pi over 3. Are we okay with that? All right. Okay, anything from the book you want to talk about? I had a book. Okay. 27. 27. Okay, so 2 sine x plus cosecant. This is 27 from 5.3, the book. It is 2 sine x plus cosecant. Equals 0. Does that look right? Okay. Interesting. Hard to get no. Well, can we just use an identity? Can we rewrite cosecant as 1 over sine? Anybody try that? Did that get you anywhere?
Well, I did that, and then I created a common denominator with sine.
So this is really over 1, but you multiply by sine over sine, right?
Yeah.
So did you get 2 sine squared x plus 1 all over sine x equals 0? Okay, I mean, I think that we can multiply both sides by sine x.
Oh, I didn't do that.
Well, okay, hear me out. We can do that,
I factored that. Am I allowed to do
but I
that?
think that, what'd you do?
Factored out a sine x. So I got 2 sine x plus 1. Sine x times 2 sine x plus 1 equals 0. Am I allowed to do that?
I don't think you can factor 2 sine squared x plus 1.
No, I just factored out a sine.
How can you factor out a sine? There's no sine here. You know what I mean?
Yes.
I subtracted the 1 over the sine x
Yeah.
and then multiplied by the inverse. So I subtracted 1 over sine x on both sides and multiplied by negative sine.
So you're saying from here, you did 2 sine x equals negative 1 over sine x?
Yeah, and then multiplied by the inverse. Of one.
So like cross multiplying kind of thing?
Yeah. 1 over the sine over 1.
So that's 2 sine squared x equaling 1
It's,
Like that?
It's
equals negative 1?
like
I mean, that's okay. I think that's okay. I just feel like we might be introducing extraneous solutions by doing either of these things. So let's go with this, because at least it looks like sine squared x equaling -1/2. So I take the square root.
Yeah, that's the problem, it was in negative, I couldn't really see anything out of that.
All right. Well, my book says for 27, no solution.
Darn.
Okay, that's what I had.
Maybe it is.
You got no suit
Well, yeah, because I'm.
Yeah, let me, yeah, let's,
Because it's a negative.
maybe we'll revisit this problem later. I just want to see how they did that, but I think that,
Don't put it on the test.
either, I think even here, like if we're trying to find out when is this fraction, like when is this fraction here equal to 0? Well, this fraction is going to be equal to 0 when the numerator is equal to 0, right? And if I set that numerator equal to 0, I still get to this point, right? Same thing that Augie got, and it's never going to work because there is no number that I could have here when I square it and multiply by 2 that I'm going to get a negative, right? Okay, anything else from the book? 45. Oh, use the graphing utility to approximate the solutions to 3 decimal places. Did you graph it on your calculator?
I did.
Oh, you graph? Oh, okay.
You got a graph?
Yeah. Want me to put a hat on?
Yeah, put a hat on.
Like, figured it out.
Um, while Danny is logging in, and he can't log in yet because I haven't turned my calculator on. Or anything else from this section that we should look at?
33.
Alexis?
Number 6, it's on, I think it's on part 1.
Number 6, you're just supposed to plug in the number and see if you get a true statement, right?
Like if it equals out.
You'd have to find, like if you plug in pi over 6 for x, you gotta find the cosecant of pi over 6, then raise that answer to the 4th power, and subtract off 4 times cosecant of pi over 6 squared,
So,
and see if you get 0.
So like the powers, you always before it when it's a trig function.
If you see cosecant to the 4th of x, that means take cosecant of x, whatever that is, and raise it to the 4th.
Okay.
Okay, let's see, hang on just a second. This is, we're going to block 3, begin class. Okay, you should be able to log in now, Danny. You're good? All right, capture class, logged in only. Okay, and make presenter. Okay, so tell us about this.
So it said it equaled 0, so I was just able to graph it, 2 sine x plus cosine x.
Yeah.
And it said the solutions, so I'm like, well, the solutions are probably, when it intersects with the x-axis.
So did you do like menu,
So I
analyze,
did menu, analyze,
zeros?
yeah, 0, and I just did that, and I got, then I put it in the trig window.
Zoom trig.
Because it was 0 to 2 pi.
Okay.
And I got 2.68 was this one, and then the other one was 5.82.
Okay. All right.
So, yeah.
Questions on how to do this?
Could you do like 2.68 plus 2 pi n?
We're only trying to find the solutions in the interval from 0 to 2 pi. So you only have to list those, looks like just those 2 values, right? Danny would be the only solutions.
So none of the negatives?
You did not have to find those, because it was only asking for the solutions between 0 and 2 pi, which is between 0 and 6.28. Okay. All right. So thank you for that. And anything else from the homework, from the book? Mary? 33. We'll make this our last one. And okay. looking at 33. It says, not another one of these. This one actually has a solution now. All right, cosecant x plus cotangent x equals 1. Cosecant x plus cotangent x equals 1, right? Can we write this as 1 over sine x plus, and this is cosine x over sine x equals 1. We have a like denominator, so I got 1 plus cosine over sine is equal to 1. Interesting. If I multiply both sides by sine x, I don't even want to do this, but if I do, okay, but then so I've got 1 plus cosine x equals sine x, right? But then if I go through the whole process of like squaring both sides and doing all that, doesn't that look a lot like problem number 7 from Gift A that we did? Alexis? Cancel out the ones, or like, I don't think so. I don't think there's any way to simplify this. Danny?
Can you square from the beginning? Or is that, no, because of the middle term?
You mean up here?
Yeah.
You can square if you
Oh, that's
want.
what I did.
But then you'd have to do FOIL. Did you end up getting like 2?
I just did cosecant squared x plus cotangent squared.
That would not be correct. You'd have to have cosecant squared x plus cotangent squared x plus 2 cosecant x cotangent x, right? Because you got to do FOIL. Okay, I guess here's my point. If we kind of try and avoid all of this stuff that we were talking about doing, like if we don't do this stuff, then can we find some place on our unit circle, some angle, where we take that angle and we do 1 plus cosine of that angle divided by the sine of that angle is going to be equal to 1. I don't know. But could it be, for example, at 0 degrees or 0 radians? Then I'd have 1 plus cosine of 0 over sine of 0. Uh-oh, what's the sine of 0?
0.
0. I can't divide by 0, so it's definitely not going to be 0. What about at pi over 2?
Yeah.
The ordered pair is 0, 1 here, so I have 1 plus cosine of pi over 2 over the sine of pi over 2. Does that work? Because cosine of pi over 2 is 0, so I end up getting 1 plus 0 over 1, right? Because sine of pi over 2 is 1, and that is equal to 1. It turns out that pi over 2 is the only answer. So I don't think that we're meant to just do this, but I think that if we did try and do, what do we end up getting? 1 plus cosine x equals sine of x. If we end up squaring both sides,
It does work, actually.
and doing the whole thing, but I bet that introduces some extraneous solutions.
Yeah, I had 3 pi over 2 also.
You had 3 pi over 2 also when you did this?
Yeah, so I like introduced it.
So I did the same.
All right. So, but you didn't get,
I got pi over 2 and 3 pi
Okay.
over 2.
okay, you only got 2 solutions that
Yeah.
time? Okay.
When
And
I
one of them was extraneous?
Well, yeah.
Okay.
No, I squared it at the
Yeah,
beginning.
yeah.
I got pi over 2 and 3 pi over 2.
But without that middle term?
Yeah, without the middle.
I'm not going to listen to you if you don't have that middle term. Okay.
Technically worked.
On a fluke, I would call that a fluke. You got the correct answer, but you had faulty reasoning, so we can't count that. Okay, so at this point, I would like to look at some things from section 5.4. All right. Section 5.4. And before I give you the gift that goes along with this section, can we, first of all, look at our learning objective. We're going to be using sum and difference formulas to evaluate trig functions, to verify trig identities, and to solve trig equations. So here's my first question for you. Is the following statement true? Is the cosine of pi over 2 plus pi over 3 equal to the cosine of pi over 2 plus the cosine of pi over 3?
Yes.
No,
No.
I hear
no.
yes, I hear no.
No, it is not.
no way.
Well, let's test it.
Get the shit.
Let's test it. If I wanted to do pi over 2 plus pi over 3, I need a common denominator here. So is that like 3 pi over 6 plus 2 pi over 6? Is that right?
Yeah.
Yeah, I'm just combining these, adding these. So on the left side, I'm really trying to find cosine of 5 pi over 6. Correct? Cosine of 5 pi over 6 is here, 5 pi over 6. My cosine here is that negative square root of 3 over 2. So this left side is equal to negative square root of 3 over 2. What about over here? Cosine of pi over 2 is 0. And then the cosine of pi over 3 is 1/2. So is this a true equation?
No.
No. So can we, if we see something like this, can we just distribute the cosine through here to get a true statement or an equivalent statement? No. So the answer to this question is a big no, no. And that's why we need some special formulas called the sum and difference formulas. All right, and I'm not going to ask, well, I'm going to ask you to learn these, but I have them for right now on our gift, which I don't know if I did now.
Oh, really?
All right.
I'm reading this on.
Okay, so our sum and difference formulas, I put them on the gift for you also. Can we just number these for right now? Okay, so let's take a look at number 1. We're finding the exact value of sine of 75 degrees. We want the exact value. So if you go to your calculator, it's probably going to give you some kind of decimal. We don't want a decimal approximation. We want an exact value. 75 degrees, though, is not on our unit circle, right? So in this case, that means that we're going to have to use a sum or difference formula. Are there 2 angles that we know of on our unit circle that could add up to 75 degrees? Dan?
Pi over 4 and pi over 3. No, pi over 6.
Well, give me degree measures.
Oh, 30 and 45.
Okay, so if we're trying to find the sine of 75 degrees, that's going to be the same as finding the sine of 30 degrees plus 45 degrees. Everybody agree? Can we say that that's equal to the sine of 30 degrees plus the sine of 45 degrees? Is that true? No, we just proved that you can't just distribute, so we cannot write this, but we can write this. And now, which formula are we going to use? 1, 2, 3, or 4? Which one fits this pattern of sine of quantity 30 plus 45 degrees? Which one, Mary?
Sine u plus b.
Sine u plus v. So we want to use the sine u plus v formula, which is sine u cosine v plus cosine plus sine, no, how's it written? Cosine u times sine v. Does that look right? And in this case, 30 degrees is our u and 45 is our v. Okay? So in this case, what are we going to plug in for what? What are we trying to find? Katie?
Trying to find 75
So tell me what to plug in here.
sine of 30
Okay?
times cosine of 45
45,
plus cosine of 30. Sine of 25.
Is everybody okay with that? So what is the sine of 30? What's the cosine of 45, and so on? What's our answer going to be for this, Marissa? You're looking at your unit circle, or maybe you just know this. What's sine of 30 degrees? Yeah.
So sine at 30 degrees is 1/2.
Is 1/2? Okay, now I don't want to write sine of 1/2, right? I just want to write 1/2, right? Sine of 30 degrees is 1/2. What about cosine of 45?
Square root of 2/2.
Everybody agree with that? Then I have a plus, and what's the cosine of 30 degrees, James?
Square root of 3 over 2.
Square root of 3 over 2, and the sine of 45 is what, James?
Square root of 2.
Square root of 2 over 2. So in this case, I'm multiplying 1/2 times the square root of 2 over 2. That gives me square root of 2 over 4. And I'm adding to that, and I get square root of 6 over 4. All right? And is that equal to square root of 8 over 4? Yes? No? I hear some people saying yes, some people saying no.
I'm not sure, but I'm going to say no.
So I guess I will ask it this way. Is the square root of 9 plus the square root of 16 equal to the square root of 9 plus 16?
No.
Square root of 9 is 3, square root of 16 is 4, this is square root of 25, which is 5. 7 equals 5. No. So we can't do that, so we can't do this. So all we can do to kind of give our exact answer would be maybe write it as one fraction. Are we okay with this? All right, let's take a look at number 2 on your gift. Which is here somewhere. There it is. Find the exact value of cosine of pi over 12. Now, you might be good with subtracting fractions to say, hey, there's 2 angles on my unit circle that subtract to give me pi over 12. But you can certainly, if you don't want to do that, you could certainly convert pi over 12, pi over 12 radians equals how many degrees, and you could convert. So what would you prefer? You want to find 2 angles on your unit circle in radians that will subtract to give you pi over 12? Or do you want to convert to degrees? All right, if you want to convert to degrees, then we're going to do pi over 12. What do we do to convert?
180 over pi.
Multiply by 180 over pi. Pi's divide out, and I get 180 over 12 degrees. What's 180 divided by 12?
3 over 2? No.
180 divided by 12.
30 over. Oh, wait, what is it? It's you divide by 6.
You can use your calculator. All right, we get 15 degrees. So really, find the exact value of cosine of pi over 12. That's the same thing as finding the cosine of 15 degrees. Everybody okay with this? Now, what 2 angles do we know on our unit circle that add or subtract to give us 15 degrees? Augie?
45 and 30.
All right, so Augie wants to use cosine of 45 degrees minus 30 degrees, because that's going to be equivalent to the cosine of 15 degrees. Everybody agree? All right, at this point, which of the sum and difference formulas do we want to use? 1, 2, 3, or 4? Alexis, 4. Number 4. So you want to use cosine of u minus v? And that formula is cosine u, cosine v. But remember, the cosine formulas, they have the cosines being multiplied together, where sine formulas do not. But they have the opposite sign. So instead of a minus, they have a plus. So this is cosine u, cosine v, plus sine u, sine v. Everybody agree? So in this case, we're plugging in 45 for u and 30 for v. And so I'm going to fill that in above here. So I'm going to have cosine of what, sine what, or what's it going to look like? Cam, what's it going to be?
Cosine 45,
Uh-huh.
cosine 30,
Times cosine 30.
yeah, plus sine 45, times sine of
Sine of 30. Everybody agree? Everybody see where we're getting this from? Okay, so I can just wow, come on. That's so dependent. So cosine of 45 degrees minus 30 degrees. Okay, are we okay with this? All right, filling in our values here, Gracie, what do we get? What's the cosine of 45? So this is square root of 2 over 2. Now cosine is square root of 2 over 2, right? Just square root of 2 over 2. Then cosine of 30? Square root of 3 over 2. And the sine of 45? And the sine of 30. Everybody agree with this? All right, and so here I get, by multiplying, I get square root of 6 over 4 and square root of 2 over 4. Can we say we're getting square root of 6 plus square root of 2 over 4 is our answer?
Yep.
Does it matter if it's like square root of 2 plus square root of 6? Or
That's okay. That's okay. That'll be the same. All right, questions on this one? Okay. Let's take a look at number 3. For number 3, it says simplify cosine of 25 degrees times cosine of 20 degrees minus sine of 25 degrees sine of 20 degrees. I'm asking you now to kind of go backwards and say this part here looks like the right side of one of those 4 sum or difference ones. Which one does it match up with? It kind of fits the pattern for one of those 4. Which one does it fit the pattern for? Augie?
3.
Number 3? That one, you're saying the right side is cosine U, cosine V minus sine U, sine V?
Yeah.
And if that's number 3, that's actually the formula for what?
Cosine of U plus V.
Cosine of U plus V. Everybody agree? In this case, does it fit that 25 degrees would be the U and 20 degrees would be the V? Is that right? So that means that over here, this whole expression is equal to the cosine of what? 25 plus 20? All right, so that's really equal to the cosine of 45 degrees. And just because of the numbers I picked for you, we actually can find an exact value, right? But if I had picked 2 degrees and 3 degrees, then we'd end up with like cosine of 5 degrees, and you would just leave your answer as cosine of 5 degrees. Does that make sense? But here we really can say, hey, this is equal to square root of 2 over 2. This is okay.
so our answer is not cosine 25 plus 20, but 45
Well,
minus
this would be, you would show this on your paper, because this is equivalent to this, but this we know is equal to this.
So
and
you always
this
want
is-
to simplify
Yeah,
it.
keep going as far as you can. Are we okay with this? All right, I want to skip over number 4, because that one is going to take us some time. But let's take a look at number 5. It says prove the co-function identity. Remember we talked about these co-function identities that, well, this is a slightly different co-function identity because it's sine of x minus pi over 2 equals opposite of cosine of x. So we're just trying to prove that this identity is accurate. So in order to do that, let's rewrite this left side, calling x as our u and pi over 2 as our v. So think of this as like sine of u minus v. So we're going to use which formula? 1, 2, 3, or 4? Number 2. So we're going to want to use, we're going to want to rewrite this as sine what, et cetera, et cetera, et cetera. Alexis, what's it going to be? So times.
Okay. Sorry. Sine U, cosine.
Yeah, let me write the formula. So sine U, cosine v,
Okay.
plus, no, it's not a plus, minus
Cosine U, sine V, So it'd be sine x, cosine pi over 2, and then minus cosine x and sine pi over 2.
And I'm gonna write, you know how we always like to write the right, when we're verifying, let's keep the right side going. We're trying to show that that's equal to negative cosine x, right? So what can we evaluate here? What is the cosine of pi over 2 equal to? What's cosine of pi over 2? 0. So I have now sine x times 0 minus cosine x times, what's the sine of pi over 2? 1. And is that going to be equal to, or trying to show that that's equal to negative cosine x? So sine x times 0 is 0. So I got 0 minus cosine x times 1 is cosine x. So are the two sides equal to each other? Yes. And we're done. We verified this identity. We've proven this identity is true using a sum or difference formula. Are we okay with this? Okay. Let's see. This is another one just like that, and I think what I'm going to do is have you guys work on this on your own. Just try this one right now. You're going to use a sum or difference formula for sine of 3 pi over 2 minus theta. I didn't give you an equal sign here, right? So you're just going to simplify it and then compare with the people around you and see if you agree on that. And I'm going to pause this for a moment. Okay. All right, who's going to talk me through this? What did you get? Augie?
Negative cosine theta.
All right, how did you do that? What did you do?
So I set up the sine of u minus v. So the u obviously was 3 pi over 2, and the v was theta.
All right, do I have my formula right?
Yes.
So you plugged in 3 pi over 2 for u and theta for v.
Yep.
So that means that the sine of 3 pi over 2 minus theta is equal to sine of what?
Sine of 3 pi over 2
Times.
cosine of theta minus cosine of 3 pi over 2 times sine of theta.
Everybody agree with that? Okay, and then what is the sine of 3 pi over 2?
Negative 1.
Negative 1. So I got negative 1 times cosine of theta minus, what's the cosine of 3 pi over 2?
0.
0 times the sine of theta. So that means I end up with negative cosine theta minus 0, which is just negative cosine of theta as our answer. Are we agreeing on this? Okay. Any others that I wanted to do? I think I would like to look at one more. Let's look at number 8. I'm assuming you're all going to be able to do tangent 1. You're going to follow the formula for tangent of u minus v and plug in theta for u and pi over 4 for v. Let's take a look at number 8. This one says find all solutions. So it's kind of like a solving problem from section 5.3. Find all solutions of this equation in the interval from 0 to 2 pi. So, but here, you're going to have to rewrite this part using a sum formula for sine, right? And you're going to have to rewrite this part using sine of u minus v, right? The subtraction formula for sine. All right? So for this one, if x is u and pi over 2 is v, you're going to fill that in like you're going to use that formula, sine u cosine v plus cosine u sine v, and so on. And then this one, you're going to have to use the other formula, sine of u minus v formula. You're going to fill in x wherever you have a u here, and pi over 2 for v. Here, you're going to fill in x for the u and not negative, just 3 pi over 2 for v, right? So go ahead and do that, simplify what you have, talk to each other on this. All right, for this one, did you fill in here sine It's supposed to be sine x times cosine of pi over 2. Is it plus cosine x times sine of pi over 2? Does that look right? And then we want this plus right here, right? And then we're filling in sine x times cosine of 3 pi over 2 minus cosine x times sine of 3 pi over 2. Does that look right? And I can't squeeze in my equals 1. We'll take this up after lunch. Okay, so with this one, as we're finishing this up, we got to this point, cosine of pi over 2 is equal to what? 0. So I get sine x times 0 plus cosine x times what's sine of pi over 2? 1 plus sine x times what's cosine of 3 pi over 2? 0. And then minus, right, cosine x times what's the sine of 3 pi over 2? Negative 1. And that whole thing has to equal what? Well, this is going to 0. So I get 0 plus cosine x times 1. This is going to 0. So I got plus 0 minus, oh, is it minus a negative cosine x? And I want to know when is that equal to 1. So it looks to me like I get cosine x plus cosine x equals 1, which means 2 cosine x. Oh. 2 cosine x equals 1. Divide by 2. We get cosine x equals 1/2. And then where on our unit circle are we only supposed to find the solutions between 0 and 2 pi? So where on the unit circle between 0 and 2 pi is the cosine equal to 1/2?
Pi over 3 and 5 pi over 3.
Do people agree with that? Okay, so I think those would be our only solutions that we would need to list here. Are we okay with this? Okay. All right. At this point, I would like to stop my. I guess I'll keep it going. We're still recording. Okay. What I want to do now is look at ACT Set 9. You folks get to have the quiz for the ACT before blocks 6 and 8.
Yes.
All right. So is there anything that we should be looking at on this one? Alexis?
Number 9.
Number 9 is here. For this one, whoopsie, I didn't want to look at that example. For this one, it says when 3 times x is increased by 5, so I wrote 3x plus 5, the result is less than 11, so I wrote less than 11, and then I just solved that inequality. So I subtracted 5 from both sides and got 3x less than 6, divided both sides by 3, and I got x is less than 2. So I know it's kind of hard to read on this, but this one is open circle at 2 and shading this way. So that's why our answer is D. Anything else we should look at here, Mary?
15.
Yeah, number 15 is one that I think we definitely need to talk about. That one involves ellipses, and you've studied these, right? And anybody else in here in honors?
Josh.
Pre-calc, yeah, but some others, but they're not here today. So we do need to talk about these. You didn't get this sheet? Okay. Let's see what I got. And this quiz. Okay, so for this one, it says, which of the following is the equation of the largest circle that can be inscribed in an ellipse with this equation? So you're given this equation. Let's talk about ellipses in general. Let's back up. Let's talk about circles in general. You know, circles have this formula, x minus h quantity squared plus y minus k quantity squared equals r squared, where the center of the circle is hk and r is the radius, right? Radius, and this is the center. Everybody remember this? Okay, but with ellipses, the formula is similar, but instead of just having it look like this is for circles. All right, but for ellipses, the formula is x minus, I don't know, do they use h and k still?
Yeah.
Yeah, x minus h squared over, what do they use?
Well, it's A or B.
A, let me use A, and then plus y minus k quantity squared over b equals 1. It's always equal to 1 over here. And depending on whether A is bigger or B is bigger, that will tell you whether your ellipse is opening in a horizontal way like this. This is if A is greater than B, right? But if the number that's below the y is bigger, if A is less than B, B is greater than A, then it's going to look like a kind of a vertically shaped ellipse, okay? What else can I say? This number here is really gives you how many units out. Let's back up.
It's from the.
Yeah, so here, if this is 16, x minus 4 quantity squared equals 16. So this one, since this is the larger number here, that means this is a, horizontally shaped kind of ellipse like this. And I know that from my center, which is still found by the h comma k, so the center for this one, center of this is still 4 comma 0, right? But the square root of this, a, is going to tell you how far out you need to go, left or right. So if I was going to graph this, and I am, so if I have this graphed, so I know that my equation, slide this over, my equation was x minus 4 quantity squared over 16 plus y squared over 4. Is this correct? Am I just remembering this correctly? Okay, so this means that my center of my ellipse is going to be at 4, 0. That's my center. I'll put a little c for center. And then I know that this is larger than this, but I need the square root of this. The square root of this is 4, and that tells me how far out to go from the center in a horizontal way, in the x direction. So I got to go 1, 2, 3, 4 out this way, 1, 2, 3, 4 out this way. So I know that my ellipse is going to pass through those 2 points. And then here, the square root of 4 is equal to 2. That tells me how far to go up or down from the center. So there I want to go up 2 and down 2. And so my ellipse is going to look like this. Does that make sense? All right. I mean, this is a topic that's taught in honors pre-calculus, but you're going to need it for this quiz. All right. So that's why I'm giving you this heads up. Okay. Now the question is, what's the equation of the largest circle that can fit inside of this ellipse? So I think that the largest circle that's going to fit is going to have to be a circle that's centered at that same center, but it only goes up, kind of looks like an eye, doesn't it? It only is going to be able to go up 2 and down 2. Does that make sense? Right? It can't be, can't be centered at 0. 0 doesn't fit inside. It's got to be fitting inside like this. So we basically need the equation of that circle. Does that make sense? But in order to get that circle, you needed to be able to graph the ellipse pretty successfully, right? So the equation of this circle is x minus h. We want to still shift over 4, right? We don't want to shift up or down for our center, so that's just y minus 0 quantity squared. equals, and what's our radius going to be for this circle? 2, so I need to square that and get 4. Does that make sense? So that's why our answer for this problem should be C. Is this okay? All right. Anything else on this? Hopefully that was enough chat about ellipses that you'll be successful if you see this problem on your ACT quiz on Thursday. Anything else we should be looking at from set 9?
Can you do number 14?
14, sure. Okay, for number 14, it says the measure of the vertex angle of an isosceles triangle is x minus 10 degrees. The base angles each measure 3x plus 18 degrees. What is the measure in degrees of one of the base angles? Well, I filled in, I drew myself a picture. I'm a very visual learner. I wanted to see this picture. So I drew an isosceles triangle. I made my the vertex angle x minus 10. I drew in 3x plus 18 for the measure of each of the base angles. And then I added those up. So 2 times the 3x plus 18 plus the x minus 10. I know those 3 angles have to add up to 180. I distributed my 2. I got 6x plus 36 plus x minus 10. I combined like terms. I got 7x plus 26 equals 180, subtracted 26, divided by 7, and I got x equals 22. But by all means, look at that. There it is, so tempting. You just want to grab it, but that's not your answer, right? Because you weren't supposed to find x. They were asking, you might want to underline what you're asked to find. What is the measure in degrees of one of the base angles? So I've got to plug in 22 in for the x in the 3x plus 18, and when I did that, I got 84. Are we okay with this? All right. Were any of you at the math session last week? Because true confession, and I told the students that were there, because we went over like 1 to 59 odd in one of our practice, in the practice book. And I said, true confession, I got all of them right except number 1. Like the one that was probably supposed to be the easiest is the one that I missed. And it's because of a problem like this, I didn't read the directions and I just grabbed the answer, you know what I mean? So that's why I'm big on like underline what they're asking, circle, all that, right? Okay, so go to school on me and don't make that same mistake. Okay, anything else that we should look at on this ACT set? Alexis.
It seems easy, but I just can't figure it out.
Number
Number 6.
6.
I don't know why I can't figure it out.
Let's see. Number 6. Come on. Number 6 says, what is the sum of these polynomials? So you're adding like terms. This is an x squared, y squared term here. And you're adding it to this x squared, y squared term here. They're like terms, so negative 2 plus 3 is 1. So that's why I get a 1 x squared, y squared. And then if I look at x squared y, and this, there's no other x squared y term, right? So I just need x squared y. And then I also have a 2xy squared, right? So I need that as well. I can't combine those, they're not like terms. So this would be my answer, would be C. Is that okay?
Yeah, because I was adding like the first 2 already, and then just.
You were trying to add these 2?
Yeah.
Yeah, they're not like terms, so you can't add them. It's like trying to add 5x and 3x squared. You just can't add them. Anything else from this? Okay. So I'm going to stop the video. Say goodbye, everybody.
Bye.